Hello friends, in this video we want to learn more about generic types in Java. Generics means parameterized types. They enable you to create classes, interfaces, and methods that the type of data upon which they operate is specified as a parameter. Using generics, it is possible to create a single class, or an interface or a method which is called generic that automatically works with different types of data. Java has the ability to create generalized classes, interfaces, and methods by using of type object. Because object is the superclass of all other classes, it can refer to any type object. So, in pre-generic code, generalized classes, interfaces, and methods used object references to operate on various types of objects, but the problem was that they were not type safety. But what is type safety? Type safety means to ensure that any variable access only its authorized memory locations in a well-defined and permissible way, or the code doesn't perform any invalid operation on the underlying object. Generics added the type safety that was lacking. It is no longer necessary to explicitly casting between object and the type of data that is actually being operated upon. All casts are automatic and implicit. So generics expanded the ability of reusing code and led to do safety and easily. Let's do some examples. T is the name of a type parameter. This name is used as a placeholder for the actual type that will be passed to generic class when an object is created. So it is used with generic whenever the type parameter is needed. Whenever a type parameter is being declared, it is specified with angle brackets, because generic use a type parameter. In the declaration of generic, there is no special significance to the name T. Any valid identifier could have been used, but most of the time the values are T or E or V. Here, T is used to declare an object called generic object. The method printType displays the type of T by calling the name on the class object returned by the call to getClass on object. The getClass method is defined by object, so it's a member of all class types. It returns a class object that corresponds to the type of the class of the object on which it is called. Class defines the getName method, which returns a string representation of the class name. Here, generic object will be an object of the type passed to T. For example, if type string or integer is passed to T, then in that instance, generic object will be the type of a string or integer. Here notice that the type string is specified with the angle bracket after generic. In this case, a string is a type argument that is passed to generic type parameter T. This effectively creates a version of generic in which all references to T are translated into references to a string. Please notice that Java compiler does not actually create different versions of generic or of any other generic class, although it's helpful to think In these terms, it is not what actually happens. Instead, the compiler removes all generic type information, substituting the necessary cast to make your code behave as if a specific version of generic were created. So there is really only one version of generic that the next line assigned to integer object or string object a reference to an instance of a string or integer version of generic class. Please notice that when the generic constructor is called, the type argument string is also specified. This is because the type of the object to which the reference is being assigned is of type generic string. So the reference returned by new must also be a type of generic string. If it doesn't happen, a compile time error will result. This type checking is one of the main benefits of generics because it ensures type safety. When we declare an instance of generic type, the type argument past the type parameter should be a reference type. It means it should be a class and not a primitive type, such as boolean, char, or int. For instance, with our class, it is possible to pass any class type to T, but you cannot pass a primitive type to it. But it is not really a restriction, because you can use the type wrappers to encapsulate a primitive type. Java auto-boxing and auto-unboxing mechanism makes the use of the type wrapper transparent. Pay attention that a reference of one specific version of a generic type is not type compatible with another version of the same generic type. For example, this will make an error. Although both int object and str object are of type generic, but they references to different types. In this way, Generics add type safety and prevent errors.